Hey, welcome to the shop. It's been a while since the last video because it's summer here, which means there's a bunch of stuff to do outside. I have a loud dog running around upstairs. That's probably a little noisy. Puppy, come here. Sit. Good boy, good boy. Yeah, so a bunch of projects to do outside with summer, spreading a lot of gravel around, fixing up roadways, working with the animals, stuff up at the barn. Have a new baby, as I think I mentioned a video a while ago. That obviously keeps me busy. A bunch of family stuff going on too. Anyway, back in the shop, I've started arranging things in here. As you can tell, I haven't put up the plywood on the walls yet. I was beating myself up over the amount of work that would need to take to do and the sort of level of quality and detail that I want to have to make it look right. And rather than just diving into it, I'm just going to start using the space, get a feel for how things work, where things should be laid out. And when I get around to doing the walls, I'll get around to doing the walls. I can stop beating myself up over that. But one thing I do want to do in this shop quickly is we have two main entrances. We have the man door, which is back that way, and then like 40 foot or 60 foot in the other direction is the garage door. The main entrance from a car or from walking from the other side of the property is on the garage door, but there's no way to get in because you have to open that up from the inside. So you end up walking over to the man door, going in and opening it up. So what I want to do is make a little keypad so that I can open up the garage door from the outside. Keypad is kind of a misnomer. It's going to be a SwitchPad. So the way that the garage door is operated is there's a 2-wire connection coming from the motor that opens and shuts the door. Those 2 wires both provide power for an LED that sits in the little button that's on the inside and also checks for contact between the two. The way I think it works, and I should probably just take the scope out and have a look. I think it probably sends an AC current in that it rectifies to turn on the diode and then looks in the other direction to see if there's contact when you press a button. Hopefully that makes sense, but it allows you to run power through it to power the LED, but also check whether the button has been depressed. So rather than making a keypad that consumes power and has a little microcontroller or something like that in there, I thought I'd get a little old school and use switches. I'll bring you in closer to show you what I'm planning. So come on over. So what we have here is a bunch of switches. These have a single throw, so on or off, up or down, but they have 2 poles. So this is the common, and when it's down like this, those 2 are connected, the common and that one are connected. When it's flipped the other way, that one and that one are connected. So basically it's almost like a normally open and a normally closed contact on the switch. I've got 10 of these, but I think what I'm going to do is use 9 of them, arrange them like a 10-digit keypad, but obviously facing out this way. Oop, you can't see. They have these little rubber grommets so that they can go outside. So I have 1, 2, 3, 4, 5, and away, 6, 7, 8, 9. No. So you'll have 9 of them, and there'll be a certain pattern of ups and downs that when you press a button at the bottom will make continuity through all of them. The reason why I have these dual pole switches is I want to have 2 to the power of 9 combinations. That's what, 512. That should be secure enough for this. If they were just normal, just regular switches with 1 pole, you could just flip all of them on or all of them off and press the button and it would work. But this way you need the particular ones on and off to make the combination that should open the gate. Hopefully that makes sense. Hopefully it'll make sense when I make it. And I think, technically it'll be reprogrammable because all I need to do is, if I want to change the code, is just rotate the switch on the back to the other way, and that'll flip a bit. So I could change the code if I want. So this is going to be mounted on the outside of the shop, so I want it to be waterproof. Hence I got these little switches that had these rubber covers on there. They just screw over the top and hopefully should protect from water egress or ingress. I've got this mild steel bar here. It's 3 inches wide. I'll probably cut out a 3 by 4 section, lay out the grid on there. I'll probably drill 4 holes and weld in some screws and or bolts and I'll tighten the nuts from the back, that way you can't take it off from the front. I'm probably doing a bit too much security engineering for this project, given that I'm out in the middle of nowhere, but hey, it's fun to do. And if I've learned anything from my years of working as a software engineer, systems engineer, the best security is the one you design yourself. That's a joke, by the way. But yeah, it's fun to design this stuff. So this should be a fun little project. I should have to drill 9 holes, 10, plus another 4, 14 holes in there, cut it off, then do some soldering to solder it all up, and this should be pretty straightforward. So I'm over at the garage door and I realized I misspoke with the switches. I totally could have done this with just regular single pole switches. I went down that path because my original plan was to use sort of latching push buttons. I was checked on Mouser and Amazon. I couldn't find waterproof exterior latching, normally open, normally closed. Push buttons under like $8 each, and I didn't want to spend that much money on this keypad. The reason why you need the normally open and the normally closed for the push buttons is they're symmetrical. There's like, you know, they're in or they're out. You can't sort of rotate them around. Whereas the switches, you can simply rotate them to change the sense of which one's on and off. So I totally could have done it with cheaper switches, but the switches were like a couple of cents each. So, God, China is amazing. Anyway, I'm over here at the keypad. I figured, not the keypad, little push buttony guy over here. I brought out the scope. I'll get some power out to this. We'll have a look and see how this thing actually works. But I'm pretty sure that all I need to do is put continuity over these 2 wires and the door will open and shut. But let's double check before I start messing around with stuff. I have a real knack for putting the camera in a way that all you can see is the back of my head. All right, I have brought the PCB to the desk for some big Clive action. So the PCB is a little different than what I was expecting. I was expecting not to have pine tar all over my fingers, which makes everything sticky. It's one of the hazards of working in this shop is pine tar has been dripping onto one of the benches and I just put my hand on it. Now I have sticky fingers. Anyway, I was expecting to see a couple of diodes in here, but I guess we do have a couple of diodes. We've got 2 LEDs here. We have a resistor, which I assume is a current limiting resistor, and the button. It should be pretty straightforward to trace what's going on here. Let's see if I can get out of the shadows. So, signal comes in through here, connects to these 2 pins here, which on one LED is going to the anode, on the other LED is going to the cathode. That sort of supports my theory that there's alternating current coming through here, and when half the duty cycle, one LED is on, the other half, the other one's on. The other 2 leads, I don't know if you can see it with the reflections, but it's not that complicated. You can take my word for it. The other 2 are connected through here. Those 2 pins are for the resistor, and then goes back out. So that portion of the circuit just means that half the duty cycle, one LED is on, the other half, the other LED is on. Then if we follow this trace through here, it comes up to one half of the button. When you close the button, it'll close those 2 connections, which would mean that this and this would be directly connected, completing the circuit. So I think that basically is how it works, but I've got the scope out. We may as well have a look at the signal and see what that looks like. Why not? Okay, that's super weird. I've got it hooked up to the scope. It's not really AC. It's got this voltage up here, which is looking like 24.5 volts. Goes to negative 350 millivolts. And it's this tiny little pulse at 81-ish odd hertz. That's not what I was expecting at all. There's probably some other explanation, but I think my theory is still fine. Just connecting the 2 wires will make the door open and close. That's all that I really care about, but this is not what I was expecting. I wonder what's going on there. don't stare too deeply into the details, I'll get lost. So enough messing around with the scope. I'm not exactly sure what was going on there. I'm sure someone smarter than me in the comments will tell me what I was doing wrong or how the circuit actually works, but I think it's good enough for what I'm doing. All right, so I'm going to try to lay out how I want this guy to look, and we'll start cutting some metal. So I think we'll have 9 switches centered up here. I think that'll look good. Just make sure that this 3x4 will actually give me enough room for everything. Yeah, I think that'll do fine. All right, let's chop this guy off and lay it all out. You know what, actually I'm going to lay it out and then chop it off. And so I have my lovely lamp here that I did in my last video. It works out really well, but the challenge with videoing with it is it makes a really bright spot, and kind of washes out the center of the video. You can tell by the speed square and the rule that this is not going to be a super precise layout, but it'll be good enough. All right, let's just double check that this layout looks reasonable. Might be being overly precious for what this is. Have enough room to actuate those? Yeah. What's the travel? Just making sure that there's enough room above and below each switch. Actually, that's another point, just to make sure they'll all fit in here. So that one will be there. That one will be there. All right, yeah, that'll all fit nicely, I think. We also need 4 coil holes in the corners for mounting. I'll set them all in 1/4 inch. My angle grinder is up at the house. I can't be bothered walking. My bandsaw is out of action right now. I will finish this off tomorrow.